Today's topic is exponents, square roots, and order of operation. Exponential expressions is what we're going to talk about first. Make sure everybody's on the same page with that. An exponent is used to show repeated multiplication of a base. So by definition, b to the n power, b is a real number and n is the positive integer. So that b to the n represents b times b times b times b, however many times n tells you to. So b is the base and n is the exponent or the power. And I'll use both of those words, exponent and power, throughout the lesson. The first set of examples says to write an exponential form and do not evaluate. So if you notice in the first example, it's just a whole bunch of fives being multiplied together. If you count them up, there are 7 of them. So you would write it in exponential form, 5 to the 7th power, because there are 7 fives being multiplied. In the second example, there are 4 9s and 3 11s. In this third example, you can do it with variables as well. There's 1 4, there are 2 x's, and there are 4 y's being multiplied together. In the next set of examples, it's asking you to do just the opposite. Instead of writing out the exponential expression, it wants you to expand it. So we have just 1 7 times 3 x's. That's what that exponent 3 means. Here, if you notice, we have parentheses around the 7x with the 3 on the outside. So that means everything in the parentheses, 7x times 7x times 7x, gets multiplied together. Now this time, they actually want us to simplify the expression. So 8 squared means 8 times 8, which is 64. In number 7, they want us to multiply 0.8 times 0.8, which is 0.64. And in the last example, they actually want us to take 1 over 8 and multiply it by 1 over 8. 1 times 1, remember when you multiply fractions, you multiply their numerators together and their denominators together. So 1 times 1 is 1, and 8 times 8 is 64. And that would be your final answer simplified. Now, the square root of an expression means that we multiply the base times itself. So to find the square root of a number means that we reverse the squaring process. So the symbol for square roots, that's called a radical sign, is used to find the principal square roots of numbers. By definition, the principal square root is non-negative. So the square of 7 is 49. So 7 squared is 7 times 7, which is 49. Well, when you reverse the order and you take the square root of 49, you get 7. Now, when we evaluate the square root of 81, the square root of 81 is 9, because 9 times 9 does equal to 81. So you are reversing the square. You're undoing the square. You can even do fractions. The square root of 4 over 9 is 2/3, because 2 times 2 is 4, and 3 times 3 is 9. So you are reversing squaring something, you're unsquaring it. Now, order of operations. A lot of you may remember, please excuse my dear Aunt Sally, from your middle school and high school math experience. So what we're going to do is we're going to follow this set order, because if we do not, we'll all come up with all different kinds of answers. So the first thing that we will do in applying the order of operations, or please excuse my dear Aunt Sally, whichever one you want to do, we are going to simplify expressions within parentheses or other grouping symbols first. Now notice that they listed a whole bunch of things that are considered grouping symbols. Absolute value bars are grouping symbols. Fraction bars and radicals are considered grouping symbols, not just parentheses. All right. In number 2, evaluate the expression involving exponents, radicals, and absolute values. Step 3, you perform multiplication or division in the order they come in from left to right. And then addition or subtraction. Notice that the word or is in both statements, not and, because or gives you the choice. If there is a division problem, first, you divide first before you multiply. So please make sure you pay attention to that. So let's get started. First thing we want to do in number 11, do we have any grouping symbols whatsoever? Do we have parentheses, square roots, absolute values, anything that they could, fraction bar, anything that they consider to be a group? And we do not. So the next thing we do is we move into exponents or square roots or absolute values. Well, we do have an exponent, so we're going to deal with that. So that would be 12 plus 18 divided by 9, because 3 squared is 9. Then I have addition or division. Well, according to my rules, I will do the division first. So I have 12 plus 2, and that produces 14. In number 12, I have a couple of symbols that I need to deal with. I do not have any big groups. So number 1, these are not big groups. This would be number 2, which says evaluate your expressions involving exponents, radicals, or absolute values. So we don't have any exponents, but we do have a radical. So we're going to take the square root of 16 and get 4. And then we're going to take the absolute value of -4, which is also 4. Now, the next thing we will do is we will do the division. So that would be 10 minus 1, and 10 minus 1 would give us a grand total of 9. In number 13, we have fractions. Now, within these fractions, I have a subtraction problem and a multiplication problem. So I'm going to do the multiplication part first, because according to my rule, we multiply or divide before we add or subtract in this scenario. So I have 7 over 8. I can cross cancel. 5 goes into 5 once. It goes into 10 twice. And then I multiply across. So that would be 1/4. 1 times 1, 2 times 2. Let me move that just a little bit because it's kind of running in. It makes it look like that's a square. So we'll try this again. We'll come over here. 7 over 8 minus 1 over 4. Remember, 1 times 1, 2 times 2. Now we have to find a common denominator. Common denominator would be 8, which means we would have to change this by multiplying by 2 over 2. So it becomes 2 over 8. And then we end up saying 7 minus 2, which is 5 over 8. And that is our final answer. So we did our multiplication first. I know it's kind of messy over here, but we multiplied first. We had to find a common denominator so that we could subtract, and then we subtracted. In number 14, I have a square root, but I have, more importantly, I have something under the square root. So this would represent what they're talking about in step 1, having a grouping symbol. So I need to get one number under that radical. So that's the first thing I'm going to do. 5 times 2 squared plus 3 times the square root of 25. Now, I've dealt with everything that pertains to step 1. So I had a radical that was considered a big group. Now I still have a radical, but the second radical goes with what they're talking about in step 2. In step 2, they ask you to get rid of exponents, absolute values, and radicals. So we're going to get rid of 2 squared. So that's 5 times 4. And we're also going to get rid of the radical, and that would be plus 3 times 5. Now, I have some multiplication. I have some or addition. So I'm going to multiply first. So that gives me 20 plus 15. And then I'm going to add for a grand total of 35. 15 and 16, I do have a group. So I have to deal with that group first. Within the group, I have to take care of the exponent. So 2 to the third would be 8, because remember, 2 to the third is 2 times 2 times 2. That's not 6, it's 8. Now I still have to get rid of that group. I need one number in that group. So that would be 10 minus 2 times 4, because 12 minus 8 is 4. Now you multiply before you subtract, and my final answer will be 2. In number 16, I have a fraction. So what I'm going to do is I'm going to do the numerator first. So I have multiplication. So I'm going to do 81 times 2 minus 4 times 3. That would be 162 minus 12, and that gives me 150. The top of that fraction simplified down to 150. Now I'm going to do the bottom of the fraction, which is 5 squared minus 10. We square before we subtract, so 25 minus 10, that gives me 15. 150 reduced by 15, or 150 divided by 15, is 10. So my final answer for number 16 would be 10. Now, here are some translations and some different words that represent addition, subtraction, multiplication, and division. Notice for multiplication and division, there are multiple ways that you can write multiplication and division. Now, order matters when you subtract and when you divide. Okay? A minus B does not equal to B minus A. A divided by B does not equal to B divided by A. So as you are working with the subtraction and division problems, order absolutely matters. When you add two numbers together, it doesn't matter if you say 2 plus 3 or 3 plus 2, the outcome is 5. When you multiply, same thing. 4 times 2 equals to 2 times 4, and they both equal to 8. But that does not happen when you subtract or divide, so be very, very careful. Make sure you are familiar with all the key words and what mathematical operation of the four they represent. So we're going to translate each phrase into an algebra expression. This says that x is added to y. So we're going to write y plus x. That shows x being added to y. In number 18, subtracted from y. So that means y minus x. That shows x being subtracted from y. Now, in number 19, we have the word decrease, which means subtraction. So x is decreased by y. So x would have to come first. So be very careful with the way that you write your problems. Now, number 20, the product. The product means to multiply the square root of 5 and x. So you can say the square root of 5 times x, or if you wanted to, you could say x times the square root of 5. It does not matter. This is the wording, that's the correct order, the way it is worded. Number 21, 6 is less than, that means subtraction. 6 is less than the absolute value of p. Order absolutely matters. Absolute value of p minus 6, okay? We cannot write it does not equal to 6 minus the absolute value of p. That's not what this statement says. It says 6 is less than the absolute value of p. So we have to put the 6 behind the p, or the absolute value of. Number 22, 3 times w added to z. So 3 times w added to z. So we're going to add 3w to z. In 23, it says 3 times the sum, 3 times the sum. So this is where grouping symbols get involved. If you're going to multiply 3 times something, that would be the sum, which is addition, of w plus z. So be very, very careful when you are doing these problems. If you have any questions, make sure you ask. Now, write the English phrase as an algebra expression and then evaluate for x is 5 and y is 2. When they ask you to evaluate, they give you values for the variables involved in the problem. So in this problem, it says the product of. So we're going to multiply two things together. We're going to multiply x and the square root of, or the square of y. So x times y squared. That's what we're going to do. The product means to multiply. The product of what? X and the square of y. Now that I have my phrase written down, my algebra expression written down, I'm going to go one step further and plug in the numbers so that I can evaluate. So 5 times 2 squared, that gives me 5 times 4, and my final outcome would be 20. If you have any questions about any of this, I know it's a lot, please make sure that you do contact me and let me know.